Hey there guys, and welcome to Moto Gumption YouTube channel. On this one we are tackling the head. We are taking it apart as well as inspecting it to make sure that there's no warp going on, as well as the surface finish is ready for a Cometic MLS head gasket. As well as checking out that frame that I had to blend out some of the gouges. We are going to use an ultrasonic gauge to make sure that not a major amount of material has been removed and that the structure and its integrity is whole. Alright, so let's get to it guys. I just wanted to take a moment to say thank you to the loyal subs out there. I appreciate you guys following and watching the content. It really does mean a lot to me. Now, for all you newcomers out there, let me drop you some details. This is the first YouTube channel that I know that's taken a naturally aspirated motorcycle, throwing a supercharger on it, and raffling it at the end of the build. Yes, one of you guys watching will be able to win this bike. Now, it will be no slouch, okay? We expect 200 plus horsepower to the wheel, about 105 to 108 pounds of torque to the wheel, and, I mean, the thing comes with a $3,900 supercharger kit. What's not to like about that, right? Now, and at the end, all the profits from the raffle will be going to St. Jude Children's Research Hospital. Alright, so somebody's winning a bike, and hey, look, it's going for a good cause. Alright, if you guys like the content, please like, subscribe, or hit the notification bell. If you guys want to make a comment, please do. Maybe suggest some stuff that you guys want to see, some tech videos, some how-tos. Let me know, and I will supply it the best I can. Enough of that, guys. Let's get to the content. Alright guys, so I'm not going to have so much of my face in this one because I want to get a very good visual on what's going on here when taking apart the head. So, sorry if you love my face, but it's not going to be showing much in this one. Now, the main thing is that I want everything to go back in the same place, okay, when we put this head back together. So we are taking it apart right now, getting all the components like the shims, the buckets, the valve springs, and the valves out of here. I will be putting them in a safe spot. That way there's no damage that can occur to them, as well as we can keep track of what position these actually came in, because I want this this bucket to go back here. I want the shim to go back underneath this bucket, because once things get flip-flopped, you have tolerances that are mixed matched, and you don't want that to happen. Clearances become tighter or looser, and you just do not want to find your clearance again on these cams once they are put back into place. I'll be putting them into this here. So each slot will house a whole I guess you say valve and assembly. So this one will have cylinder 1's intake valve, as well as bucket, valve locks, and all that stuff that goes into that one assembly. Now the first things first is I will be removing the buckets and just like that, guys. So anyways, you want to have a handy dandy little magnet available so it can be easier to take these buckets off. Now the one thing is you want to make sure that that shim is actually in there, alright, because if you leave it in here somewhere, you might lose it as you take off these springs, and you can damage that shim as well. Now I'll be leaving the oil on there to help any kind of corrosion that may build up, but hopefully this process does not take long, okay? And I'm going to stay with one piston at a time so I do not lose track, okay? When taking apart one of these, you do have to have, or actually a lot of motorcycle heads, you do have to have a special tool. Now there are certain, I guess you could say, jerry-rig kind of ways that you can take this apart, but you want to be careful not to damage any of these stuff. You also want to be sure that these valve locks on these valve springs do not just pop off, because they're highly compressed right now, and they can and will jet on you. And then have fun trying to find those inside the shop. Before I do start this, I'm going to go ahead and remove these as well. And you do need a special tool. This tool costs about $45 on Amazon. You can find it on eBay and some other places too. They do have some bigger name brand tools that offer a similar setup. Now this one comes with multiple attachments. Particularly, this is the one that we're going to need right here. This is a 19 millimeter outside diameter. So if anybody working on an FZ1 or a Yamaha R1, 2004, 2006, this is what you're going to be needing. All right, with the inside diameter All right, if I get my camera, 17 mil, all right? So your retainer will go right here. Once you apply pressure, okay, you're gonna have a spot in here where your valve is showing, and you can remove your locks, and that way your spring will come undone and your valve can fall through. Now this is one of the safer tools to use. This right here will surround your head. Your head will go in right here. You have one spot over here which will apply pressure to the bottom of the valve or the valve head. All right, so that way it does not move. And then you have this side right here which will slowly compress the spring and allow you to remove the lock and have the assembly undone. Let's go ahead with an exhaust one. Try to go ahead and loosen it with just a screwdriver. There we go, magnetic screwdriver works. So here are these little pieces, and I will show you. These guys are tiny.
Now I could tell just by looking at you. You had a little winner. Some tiny. Oh yeah.
Okay, so if you guys lose these, you're screwed, all right? I'm gonna be doing this for all of them. We have a retainer, we have our spring. If you push down, here's your cute little valve. Little bitty guy.
Little winner. Some tiny.
And stuff like this makes 200 plus horsepower. So this is one valve assembly, I should say, minus the buckets and the shims. And this is what it looks like bare. All right, all the valve train components are now out of there, which is nice. That took quite a bit of time. I'll show you the back side. All right, now the next thing is I will be taking this and putting it on a surface plate, which if any of you guys know what that is a very, very flat surface that is precision milled, and I will be cleaning off this this excess gasket material, and that we put on the surface plate, and I was making sure that this is flat all the way around, as well as getting a perfilometer onto this area here to show you that the surface finish suffices for a MLS head gasket. So a lot of work going into this, but we'll make sure it is right, because you will build it right or build it twice, and I am not doing that. What I'm gonna do is I'm gonna go ahead and get this extra gasket material off with basically some material that is softer than the head itself. Now you can use a razor blade to remove this. You'll get it off a little faster, but you have more of a chance of nicking the corners or nicking probably a passageway by either the combustion chamber or maybe an oil or a coolant channel. You don't want to do that. So I'm just going to use some basic aluminum, something that I know is for sure softer than this right here. You can slightly scratch it, but you're not going to be able to even feel it into the surface of the material. So I'm gonna go ahead and do that. I've already done this side, which is actually pretty clean. It doesn't take too much longer than a razor blade, and it's a lot safer. So I'm just gonna go ahead and start doing this. All right, so now we got the head on a big granite surface plate, all right? This here has pretty much one of the best finishes you can get for, I guess you could say a table, but I have this on here. I have no gaps underneath the head, but just to be sure, what I'm going to do is I'm going to get some feeler gauges. I'm going to start off with a 4/1000 feeler gauge and then a 1.5 and go all the way around. Just make sure there's no gapping or warping, I should say. This particular feeler gauge is pretty much just 4/1000 thick. I'm going to go ahead and go through all of the outside of the part. So just like this, all the way. And as you can see here, this tiny little piece of metal is 1.5 thick. So we're going to cut that tolerance even more. We're going to go around the outside surface of the head and check it the same way I just did, just to be sure that there's no warping. So the next thing is, since we know that this bottom half is straight and not warped, I should say flat, what I'm gonna do is I'm gonna flip this over, and now I'm gonna check on the insides to make sure that it's flat and not warped, where the actual combustion cylinder or chambers are at, because that's where all the heat's happening and that's where the warping and distortions will happen. So I'm gonna flip this over and we're gonna test it then. This here bar has been precision milled to make sure that it's square on all sides and is straight. Now I'm going to sit this across long ways at a diagonal slant. So here is the 1.5, you can even see it, the 1.5 thick feeler gauge. All right, we're going to go ahead and run across this. This is what a performer looks like. This little needle right here will drag across the surface and then drag back, and actually it goes up and down, hits all the pores, nooks and crannies, and it pulls out a reading, and it lets out, or it tells you what the surface finish is of whatever surface that it's scribing on, or I guess testing on. So here's what it looks like. Okay, and this surface plate has a surface finish of 13. Now that's actually very freaking smooth. You've seen the surface finish of that surface plate or surface table. Now we're gonna go ahead and test the head on multiple areas just to show what it's actually gonna read. And I'll give you guys a little graph of what it's gonna look like. We have 721. Okay, go ahead and just test it right there. And 448. All right guys, so this actually tested very, very well. A lot better than I thought it would. Not that I had any doubts on it, but I mean the surface finish is a lot better than I thought it would be. I mean the surface plate over there was getting 13 to 15, which is awesome. Okay, let me just say glass, smooth glass gets about 0.5. Okay, this is seeing 4 to 7, and most of these were all 4 checks, which means this thing is great. Now MLS gaskets need a very smooth surface to seal properly. All right, MLS gaskets are basically multi-layers and they're sprung. Okay, so when you collapse them in, they seal. Both sides of the gasket has a nitron coating to seal oil and coolant passages. So that helps. You can't have any grooves, you can't have any twists, especially twists or warping in the head. That's where you're going to come in that's when big problems are going to come into play. So we checked the flatness, we're good. We checked the surface finish, we're amazing. Okay, so this head is pretty much ready to go right back on, but we have to port it, and I can't wait to port this. Hopefully we gain a little bit of horsepower, but I just want a little bit better flow and ease of the engine without, you know, stressing it out even more. From here, what we're going to go do is I'm going to go home and I'm going to go test that frame. We'll get back to it, guys. See you in a little bit. All right, guys, and we're back in the garage. Now, I have the 2 bikes set up right next to each other, so that way I can go ahead and test one bike and then move over to the next one. On my personal bike, which is going to be the control bike, I'm going to be testing the side of the frame right here. This is where the wall thickness is true and how it came from factory. And then I have the frame over here that I performed the sanding to remove the gouges and the scrapes from when it went down. Now, I want to make sure that not a lot of material was removed. That's the main concern. So this is where the testing begins. How will I test it? Well, I have on hand an ultrasonic thickness gauge and, well, a little bit of some fun lubrication. Okay, so first what you're going to do is you get your personal KY jelly and you're going to go ahead and pop it open. You're going to put, oh yeah, baby. You're going to go ahead and put some in your hand, and you know what's next, guys. Oh yeah. And after you have the lubrication in your hand, the next thing you want to do is take off these pants so you have access to where you're going to be applying lubrication and testing with the ultrasonic gauge, guys. You know what? You are perverted. All right, guys, so this is what the ultrasonic thickness gauge looks like. All right, sends ultrasonic waves out through this little end right here, and it takes the reading. All right, now this right here can measure a good range of thicknesses. What we're going to be doing is testing just right here in this general area. All right, because this is where we're actually going to be having the sanding on the other motorcycle. So I'm going to take a little bit of that KY jelly, personal lubricant, because just like ultrasound, all right, looking for a heartbeat, or, you know, looking at an infant inside the womb, or say infant, looking at a baby inside the womb, this right here helps the ultrasonic waves go through the material better. So I'll go ahead and put a little bit on there. This is my first time using KY jelly, guys. Anyways, so we're gonna go ahead, we're just gonna go ahead and take some readings, see what this checks. So, all right, looking like we're seeing just in this general area, 340, 309. So it thins out a little bit right here, 340 to 350. 340. All right. Like I said, this is just the general area. So I'm gonna say 340 to 355. I mean, it did hit 1.3. There we go. So 340 to 360. Now this is a casting that's welded together. All right. This is not machined. So you're gonna have some variations in there. That's just castings in general. This is not aerospace castings. All right, so we're gonna go ahead and hop over to the other bike, do the same thing and see what we get. Get some of the lube on there. I mean, ultrasonic jelly, all right, guys? Ultrasonic jelly, is that what you call it? Sure. And this, my fellows, will be my second time ever using personal lubricant. Anyways, so just make sure to get a good amount on there. So as you can see, 340, 330. We have one little spot, most likely there's a deeper gouge. That's it goes a little low, but we have 340, move a little more, 320, 320, 328, 330, or is that 3? Yep. So I mean, realistically, we removed very minimal material here. That's actually really great. I'm happy to see this. So I'm no structure engineer, but I do know we removed very minimal material just to get those gouges out. And what I'm gonna do next is I'm gonna go ahead and just clean off this lubricant on both bikes and call it a day, to be honest. But guys, that's how you use an ultrasonic thickness gauge. Not to be perverted or anything, but personal lubrication is the best for multiple things. All right, guys, another episode down, another day of progress. A very informal video. Hopefully you guys found some value in it and something of value you could take to the bank. Maybe use in a later future maintenance that you need to do. I don't know. Anyways, on the next one, we will be working on the head, porting it, all right? Making some transitions in there, some better airflow for the head, and putting it back together. Hopefully I can put that back into the bike and we can start on the other stuff like, you know, the fuel system. Oh gosh, I love the fuel system. It's so fun to drill into the tank. Just kidding. Anyways, that's all I got for you guys now. I will see you on the next one.